Hi. My name is Blob. I'm just about to make a cup of coffee for myself while we chat. Oops. I must have added salt instead of sugar. Let me try to remove the salt from the cup. Now, I'm in a mess. I wonder how you separate a solid from a liquid, or even a liquid from a mixture of liquids. Any ideas?
This lesson is about the different methods that can be used for separating the components of a mixture. By the end of this lesson, you will be able to identify the most appropriate method of separation of a given mixture using magnets, evaporation, filtration, centrifugation, a separating funnel, sublimation, chromatography, distillation, and crystallization. You may come across several types of mixtures in daily life as well as in the laboratory. Mixtures can be classified on the basis of their physical states. Solid mixture. Metal alloys are actually solutions of solids in solids. For example, brass is a solution of zinc in copper. Solid, liquid mixture. A sugar or salt solution is an example of a solution of solid in a liquid. Liquid, liquid mixture. Alcohol in water is a liquid in liquid mixture. Liquid, gas mixture. For example, carbon dioxide mixed in water. Gas, gas mixture. Air forms a gas in gas mixture as it is a solution of gases like oxygen, argon, nitrogen, and carbon dioxide. If you are provided with a sample of a mixture and asked to separate the constituents, you first need to figure out the type of the mixture.
Hey. That's so cool. Though I don't know why this happened.
You can separate a mixture of sulfur and iron filings by passing a magnet over it. The iron filings will get attracted to the magnet and will stick to it. You can use this method to separate a mixture in which one of the components is a magnetic material.
Now I get it. I've been trying to remove the salt from the solution, but it doesn't seem to be working.
You can separate salt from a solution by evaporating the water from the solution. Evaporation is the process in which a dissolved solid substance is obtained from a solution by allowing the solvent to vaporize. Let's take a look at this process through a demonstration. Take a common salt solution, put it in a china dish and heat it gently. You will observe that the water evaporates and the common salt is left behind in the china dish as a white solid. Evaporation is used to separate a mixture containing a non-volatile, soluble solid from its volatile, liquid solvent.
Oh no! I forgot to use a strainer. Now I've got tea leaves floating inside my teacup.
Using a strainer to strain tea leaves is very similar to the process of filtration. Filtration is the process by which insoluble solids can be removed from a liquid by using a filter paper. A filter paper is a special type of paper which has pores that are tiny enough to let only liquids pass through it. If you pass a solution through filter paper, any undissolved solid particles will get left behind on the paper, whereas the liquid will filter through. The liquid that passes through is called the filtrate, and the undissolved solid particles are called residue. Imagine you want to separate a mixture of chalk powder and water. For separating this mixture, first take a round strip of filter paper, fold it into half, then into a quarter, then open it in the form of a cone and place it in a funnel. Fix the filter paper to the funnel using a few drops of water. Now pour out the mixture slowly with the help of a glass rod. The filtrate collects in the beaker and the residue is left behind on the filter paper.
I am trying to turn this cream to make butter. I'm really tired. I wonder if I could get butter by just filtering the cream.
The particles of fat in the cream cannot be separated into butter simply by filtering the cream. The fat particles are too small and will pass through a filter paper. You can separate such mixtures of solids and liquids by the process of centrifugation. The principle is that when the liquid is spun rapidly, the denser particles are forced to the bottom and the lighter particles stay at the top. Centrifugation is used for blood and urine testing in diagnostic laboratories, in dairies to separate butter from cream, and in washing machines to squeeze out water from clothes.
I accidentally poured oil into this glass of water. How do I separate the oil from the water?
When two liquids do not mix, they form two separate layers and are known as immiscible liquids. These two liquids can be separated by using a separating funnel. A separating funnel is a special type of glass funnel, which has a stopcock in its stem to regulate the flow of liquid. To separate a mixture of oil and water, follow these steps. Pour the mixture into the separating funnel with the tap closed. Let the mixture stand undisturbed for some time. Two layers separate out. Oil being lighter forms the top layer and water forms the lower layer. Remove the stopper and open the tap to run the water layer into a beaker. You will be left behind with just the upper layer of oil. In fact, the same method of separation is used to extract iron from its ore. The slag and molten iron form two distinct layers inside the furnace. The lighter layer of slag is removed from the top and the molten iron gets left behind.
Great idea. My teacher asked me to separate sodium chloride from this mixture of sodium chloride and ammonium chloride. Someone please help me.
Ammonium chloride changes directly from the solid to the gaseous state on heating. This is known as sublimation. So, to separate a mixture that contains a salt and a sublimable solid, such as ammonium chloride, you can use the process of sublimation. Take the mixture in a china dish and cover it with an inverted funnel fitted with a cotton plug. Heat the mixture. In a short while, you will see vapors of ammonium chloride. Stop heating and allow the setup to cool. You will see a fine white powdery deposit on the sides of the funnel. This is solidified ammonium chloride. Solids like camphor, naphthalene, and anthracene are examples of solids that sublimate.
That was easy. First, take a thin, long strip of filter paper. Use a pencil to draw a line on it, about 3 centimeters above the lower edge. Then, put a small drop of black ink on the filter paper in the center of the line, and allow it to dry. Finally, lower the filter paper into a jar containing water, so that the drop of ink on the paper is just above the water level. Don't disturb the jar. You will see that the water rises up the filter paper. But why are there different colored spots on the paper strip?
The ink has water as the solvent, and the dye is soluble in it. As the water rises, it takes the particles of dye along with it. Since a dye is made of 2 or more colors, the color which is the most soluble rises faster and higher. This is why there are differently colored spots on the paper. This process of separation is called chromatography. This method gets its name from the Greek word for color, chroma, as it was first used for separating colors. Chromatography is specifically used to separate a mixture that comprises solutes that dissolve in the same solvent. The technique we have just seen of using paper to separate the components of ink is referred to as paper chromatography. Chromatography is used for separating colors in a dye, pigments from natural colors, and drugs from blood.
I have to separate a mixture of acetone and water. How do I do that?
To separate a mixture of water and acetone that form a miscible liquid pair, set up the apparatus as shown in the diagram. Put the mixture into a distillation flask. A distillation flask is a round-bottomed flask with a tube at its neck. This tube is attached to a Liebig condenser. The Liebig condenser is a long glass tube within a glass jacket with an inlet and outlet for water. The open end of the flask is fitted with a one-holed rubber cork through which a thermometer is introduced. Heat the mixture. You will see that the acetone, which has a lower boiling point, vaporizes first and then condenses in the condenser. It can be collected from the condenser outlet. Water gets left behind in the flask. This process of conversion of a liquid into vapor by boiling and then recondensing the vapor into liquid is called distillation. This method is used for the separation of a mixture containing 2 miscible liquids that boil without decomposing and have a large difference between their boiling points.
What if the boiling points of both liquids are close to one another?
In case the difference in the boiling points of the liquid is less than 25 Kelvin temperature, you can use the fractional distillation method. Let's take an example of 2 such liquids, N-hexane and N-heptane. As you can see in the diagram, the apparatus is almost the same as used in distillation. The only difference is that a fractioning column is fitted in between the distillation flask and the condenser. A simple fractioning column is made up of a tube packed with glass beads. The beads provide the surface for the vapors to cool and condense again and again. The fractioning columns obstruct the smooth upward flow of vapors. During this process, only the vapors of N-hexane, which has a lower boiling point, pass through and get condensed in the condenser. N-heptane, which has a higher boiling point, condenses and flows back into the distillation flask.
Phew! That sounds complicated.
Not really. Let's try to understand the process. Air is made up of different gases like nitrogen, oxygen, and carbon dioxide. These gases are separated from one another by the fractional distillation of liquid air. Here are the steps in this process. Air is compressed in the compressor and cooled in the refrigeration unit. Thus, the air gets liquefied. The liquid air is passed through a filter to remove impurities and then fed into a tall fractional distillation column from near its base. The apparatus is warmed. On warming, liquid nitrogen boils off first to form nitrogen gas as it has the lowest boiling point of minus 196 degrees centigrade. This nitrogen gas collects at the top of the fractional distillation column. Liquid argon has a slightly higher boiling point of minus 186 degrees centigrade, so it boils next. It collects as argon gas in the central part of the fractional distillation column. Liquid oxygen has the highest boiling point of minus 183 degrees centigrade. It boils last. It collects as oxygen gas at the base of the fractional distillation column. If you want to obtain only oxygen gas from the air, separate out all the other gases and collect just the oxygen gas. The diagram shows you the apparatus that is used for separating oxygen from air. Take a sample of impure copper sulfate in a china dish. Dissolve the copper sulfate using as little water as possible. Filter the copper sulfate solution. Next, evaporate the water from the solution so that you get a saturated solution. Cover the solution with a filter paper and leave it at room temperature to cool for a day. Don't disturb the setup. After a day, you will find crystals of copper sulfate in the dish. This time, the crystals will be pure. This process is called crystallization. It is used to purify solids.
Why can't we just evaporate an impure solution to get a pure solid?
When you heat a sugar solution, for example, the sugar may get charred when you heat it to dryness. On evaporating the solution, the solute may still not be pure as it may contain impurities left over from filtration. This is why crystallization is a better method. Crystallization is used for purification of salt that we get from seawater, and separation of crystals of alum from impure samples.